Hi everyone, welcome back. In this video, what we will see is what is a zero of a polynomial. Okay, let's get started. First things first, let's take a polynomial. Let's say, suppose we have a polynomial which says 4x minus 3. Okay, let's take a very simple polynomial. X minus 3, that's it, that's the polynomial. Now, I'm going to call a person as a zero of a polynomial if that person makes this polynomial to be 0. To understand it better, first of all, let's understand something called value of a polynomial at x equal to some value. Let's say we call it as a. What do I mean by that? It's simply I need to calculate something called p of a. And how do I do that? You see here I have x here. Whenever x is there, I am just using that x and subtracting 3 from it. That's all this polynomial does, right? So I'm going to do the same job here. So wherever x is there, I need to replace it by a. So that's a minus 3. Now, since we already know that the a value is constant and it's been given to you, now this another a minus 3 will become another constant, and hence this will be considered as a value of the polynomial. Not everywhere at x equal to a. Okay, fine. Let's take an example. For example, let's say value of a polynomial. Let me actually introduce a new notation for that. Now let me call it as p of x, and then I will write a vertical symbol like this, and I will say that x equal to a, which is we usually denote it as p of a. Remember, note this, actually whatever I am doing here is I am going to write this particular portion. I'm going to read this notation with whatever I have written over here. That's all. So if I write p of x and vertical line and then x equal to a, what I will do is I will read it as the value of the polynomial p at x equal to a. That's all I will read it. Now already I have told that the way actually you found out is p of a. So that's what I have written over here, and I know that that is a minus 3. Okay, fine. That means, for example, p of x at x equal to 2 would be equal to p of 2, and that would be equal to 2 minus 3, and that is minus 1. That means the minus 1 is over here is the value of the polynomial p at x equal to 2. Similarly, let's take another example. Let's calculate p of x at x equal to 3, and that would be equal to p of 3, and that is 3 minus 3, which is equal to 0. Now similarly, let's take one more example. P of x at the value of polynomial p at x equal to 4, and that is equal to p of 4, and that will be, remember that was x minus 3, so 4 minus 3, which is 1. Now let's take one more example. The polynomial p has a value at x equal to, let's say, 6, which is p of 6, and that is 6 minus 3, and that is equal to 3 over here. Okay, fine. Now among all of the things that what we have actually seen so far, now which number or what is the number which makes the value of the polynomial is 0? So now you see here I have a value of the polynomial is minus 1. That means that's not the number I am searching for. But look at here, I have a value of the polynomial is 0. That means if I place 3 in place of the value of x, I am going to get the value of the polynomial is 0. Now what we are going to do is, this is a special number. You see that any other number is not going to give you that. Only this number 3 is going to give you that. Okay. Sooner or later, I'm also going to say that if you are having a linear polynomial, you can find exactly one person like this, which will have this particular scenario. Otherwise, you will not have anybody else. Now, quickly, what we are going to say here is, this person 3 over here is going to be called as the 0 of the polynomial. Don't get confused with whatever we have, the 0 over here and what we are calling as a 0. So here we are not calling 3 as a 0. What we are saying here is he is actually giving you the 0 of the polynomial. In other words, in short, what we are going to call is the 3 is the 0 of the polynomial p of x. Okay, let's go back and then find out some more examples. So what we are going to do here, which we said here is, over here if you substitute 3, then only you will get 3 minus 3 is equal to 0. Therefore 3 is, I supposed to write only a 0 of the polynomial, and just now I mentioned that any linear polynomial will have exactly 1 0 of the polynomial. I will tell you in a moment, I'll show it in graphically. So I can confidently write 0 is the 0 of the polynomial. 0 of the polynomial p of x. Let me write simply p of x. Okay, fine. So that's the first example. Let's take another example. Let's say suppose p of x equal to x square minus 5x plus 6. Okay, I'm at this point I'm not really asking you to solve this problem and find out the answer, but all that I want you to verify here is check for what is the value of the polynomial at x equal to 2. Now what is that? That is simply p of 2, and that means that is, remember I have a x square over here, that means the 2 square. I have a minus 5x over here, that means this is minus 5 times 2, and I have plus 6 over here, and that means this is plus 6, and that finally brings down to, this is 2 square is 4 and 5 2s are 10, so the minus 10 and plus 6. And I already know that 4 plus 6 is 10, and this is minus 10, and hence this is going to give you 0. That means evidently what it says is the value 2 or the x value 2 makes this polynomial to have the value of the polynomial as 0. In other words, the value of the polynomial p at x equal to 2 is 0. In other words, we are going to call 2 is a 0 of the polynomial. I want to stress the word called a over here. Actually, let me write simply p of x, because I do actually stress the word called 0 over over here because of this reason. Let's take one more value in this place. Now here, along with 2, let's also check the same p of x value at x equal to 3. Now what is that going to be? That is going to be p of 3, and that will be equal to, remember again, it is x square, that means 3 square, minus 5 times x, that is 5 times 3, then plus 6. And finally what we'll get is 3 square is 9, minus 5 3s are 15, plus 6. Now I know I can add these two, that will give you 15, and here is the minus 15, so that's minus 15, and that gives me 0 here. Hopefully that's correct. And that means what? What we have actually again found here, at the value of x equal to 3, the polynomial value is actually 0. That makes this x equal to 3, or in other words, simply 3 is a 0 of p of x. So depending on your polynomial, there can be 1 0 or there can be 2 zeros of the polynomials. You see here in the previous case I said I have taken a linear polynomial, I have confidently written that 3 is the only 0 of the polynomial because of the confirmation that I had. I will show it in later. But here in the case of quadratic polynomial, I was able to find 2 different people who are actually giving you 0 as the value of the polynomial. So this is something called 0 of the polynomial. Let's quickly look at actually what does this mean in the diagram, or what does actually it means in the geometrical way. So for that I will use a famous mathematics tool called GeoGebra. You can see that that is simply a drawing tool that I can plot it anything I wanted in the Cartesian plane. I can verify that what is it 0 or what is it all of them. Okay, fine. Remember the first example that we had is something called x minus 3. Alright, now you can think of that this is a polynomial. Now the moment I actually type x minus 3 over here, you can see that the green color line appears over here, right? And that actually confirms what we have learned in the ninth standard that any linear polynomial is actually is a straight line, correct? Okay, let's keep that as. Now, what is the zero of the polynomial? What I mentioned. Now, you see here, what I was looking at. Remember, I said 3 was the zero of the polynomial. Now, if you look closely, what happens here is at the value of 3, what is actually happening over here is this particular portion is actually intersecting the x-axis. If I zoom out a bit, you will understand what's happening here. You see here, this is the x-axis over here, and this is the y-axis, and exactly at equal to 3 is going to be intersecting the y-axis, x-axis, right? That makes me to a little confirm, or that makes me to come to the conclusion that, oh, that means zeros of the polynomial is nothing but wherever it intersects x-axis. Yeah, actually that is absolutely true, but we will also verify it with something else as well. Now remember, we also had another example. What was that? That was x square minus 5x plus 6, right? So let me plot that as well. X square minus 5x plus 6. Now immediately you would have noticed that is actually forming something called a parabola. If you are not aware of it, this is called a parabola. Now the moment actually you zoom in to the x-axis wherever the function was here, let me for a moment I will hide the line here. You see that here what happens here is there is a 2 over here and there is a 3 over here. In other words, the graph of this polynomial is intersecting the x-axis exactly at 2 and 3. So now you see that in the workings whatever we have done, we also have found that the 2 is a zero of the polynomial and 3 is a zero of the polynomial. And that makes what is the geometry of this zero of the polynomial. So here I can actually simply write that geometry right away here. We'll see more examples in future lessons. So don't worry if you don't understand anything right now at this moment. So what is the geometry? It's simple. The point x equal to a such that p of x intersects the x-axis is a zero of the polynomial p of x. Hopefully that makes sense. What I'm saying here, if you go back to the diagram over here, you see this is the polynomial. The point x equal to 3 is making the polynomial to intersect at x-axis. In other words, wherever the polynomial p is intersecting at x-axis, those points are actually going to be called as a zero of the polynomial. Okay, so let me zoom out a bit. Let me also take a screenshot of it and place it in our that's copy to clipboard, and let's come back over here and I'll paste it here. Yeah, that makes sense, I guess. So here, as I already mentioned, now you can see that 3 is one place that it intersects x-axis, 2 is one place it intersects x-axis. That means both of them are zeros of the polynomial p of x, which was x square minus 5x plus 6. Alright? Alright. I think that brings this particular lesson to a close, and we will see more examples in the next lecture. I'll see you in the next lecture, guys.